Good day, everyone. Welcome to this channel. Awwaludeen Made Engineering Easy. In this channel, we simplify engineering course to the lowest step. Engineering courses are not supposed to be hard to us. It depends on the way we are being explained to. So I assure you that in this channel, I break everything down step by step in the sense that a 13 years old child will understand. So today we are starting from transport phenomena, diffusivity of a gas mixture. So transport phenomena simply mean the study of how things like matter, energy move or flow from one point to another. Transport phenomena is all about understanding how matter, energy, and momentum are transferred inside a system. And we have three various types of transport phenomena. We have mass transfer, which have a coefficient of diffusivity. We have momentum transfer, which have the coefficient of viscosity, and we have heat transfer, which have the coefficient of thermal conductivity. Today, we are starting with diffusivity. Is the coefficient of mass transfer, and this mass transfer is the movement of matter or molecule from high concentration to low concentration. The example is the gas molecule diffusing through porous rock or gas separating from oil. The coefficient of this mass transfer is diffusivity, as I have already mentioned. Today, we are going to estimate the diffusivity of a gas mixture, which is carbon dioxide to nitrogen mixture. So before we start, make sure you like, subscribe, and share to your mates. Help them in passing their exam. Let's start. Solution for part A. The question says estimate the diffusivity AB for carbon dioxide to nitrogen at 273.2 Kelvin and 1 atm. A. Using Slattery Equation. B. Using Chapman Enskog formula for an ideal gas situation. C. If the gas pairs of carbon dioxide and nitrogen were to be at 150 degree Fahrenheit and 1470 psi, what will be the diffusivity AB using the value obtained from A? That is value obtained from using Slattery Equation. So now that we are starting from part A, which is using Slattery Equation, the formula for Slattery Equation using Slattery Equation, diffusivity AB equal to A multiplied by B multiplied by C multiplied by D, all divided by P. So we are going to explain what A is meant for, B is meant for, C, D, P respectively. So A, where A is what? PCA multiplied by PCB raised to power of 1 over 3. PC is the critical pressure. B is given as TCA multiplied by TCB, where TC is the critical temperature. So the next thing is C, which is equal to 1 over MA plus 1 over MB. Sorry, in this B we have all this power of 5 over 12. Sorry, that is a correction. So C, we have C equal to 1 over MA plus 1 over MB, all is power of 1 over 2, where M is the molar mass of the various gases. Molar mass of the various gases, and we have D equal to A into bracket T divided by square root of TCA multiplied by TCB, all raised power of B, where A and B are constants. A is equal to 2.745 times 10 raised power of -4, while B is equal to 1.823. So T is the actual temperature from the equation. So, and I've already explained, TC is the what? Critical temperature of various gases. P is the actual pressure from the equation. So the next is to find the respective parameter. So before we do that, let carbon dioxide equal to A and nitrogen, that is N2, equal to B. So we are going to make use of a table called property table of transport phenomena. So in this table, we can get critical temperature, critical pressure, molar mass, and even we can calculate our molar mass ourselves. We can get our molar mass and other parameters that are here. We label carbon dioxide as A, label nitrogen as B. So we have a table like this, that is gas. We have critical pressure, critical temperature, and molar mass. Have a table like this so that your work will be neat. So label under the column of gas, you can label it as A, that is for carbon dioxide. So label the second one as B, that is for nitrogen, diatomic, mind you. So check this property table for transport phenomena. If you need it, you can mention in the comment section. I'll find a possible means to get it for you. Please don't forget, make sure you like, subscribe, and share. So let's continue. Check this property table for transport phenomena overlay. You can see that under the critical property, you can see critical pressure, critical temperature, and molar mass. So check the column of critical pressure. So corresponding to carbon dioxide. So you can see the critical pressure as 72.8. Yeah, you can see it as 72.8 atm. Check corresponding to nitrogen. That is the same column corresponding to nitrogen. You can see the critical pressure as 33.5. Yeah, 33.5 atm. You are done with critical pressure. Check the column of critical temperature corresponding to carbon dioxide. You can see that the critical temperature for carbon dioxide is 304.2 Kelvin. That is 304.2 Kelvin. And check corresponding to nitrogen, that is the same column corresponding to nitrogen. You can see that is 126.2 Kelvin. 126.2 Kelvin. So check the molar mass. You can see the first column is the column for molar mass. Check it corresponding to carbon dioxide. You can see that is what? 44.01. So check the same column check corresponding to what? Nitrogen. You can see that is what? 28.01. Now, to get A, we have A equal to PCA multiplied by PCB, all is power of 1 over 3, which is equal to PCA. From the table above, we have PCA as 72.8 multiplied by PCB, which is 33.5. All is power of 1 over 3. We have it as 13.460. So next is to get our B, which is TCA multiplied by TCB, all is power of 5 over 12, equal to TCA, that is the critical temperature of A, 304.2, multiplied by TCB, critical temperature of nitrogen, 126.2, all is power of what? 5 over 12, equal to 81.300. C is equal to 1 over MA plus 1 over MB, all is power of 1 over 2. We have MA as molar mass for A, that is 1 over 44.01 plus 1 over MB, which is molar mass for B. Molar mass for nitrogen is 28.01. All is power of 1 over 2. We have it as 0.242. The next thing we calculate D. D is equal to A into bracket actual temperature, all divided by square root of TCA multiplied by TCB all raised power of B. And I've already mentioned that A is equal to 2.745 times 10 raised power of minus 4, and B is equal to 1.823. The next thing is to substitute the parameter. We have D is equal to A, which is 2.745 times 10 raised power of minus 4 into bracket actual temperature. That's from the equation. We have it as 273.2 divided by square root of TCA, that is critical temperature. From the table, we have TCA as 304.2 multiplied by TCB, which is 126.2, all raised to power of B, which is what? 1.823. We have it as 5.032 times 10 raised power of what? Minus 4. So the next thing we are going to do is to substitute into the Slattery equation. Mind you, we have Slattery equation, that is diffusivity AB equal to A multiplied by B multiplied by C multiplied by D, all divided by what? Actual pressure, which is equal to A, we have it as what? We have it as 13.460 multiplied by B, which is what? 81.300 multiplied by C, which is 0.242 multiplied by D, which is what? 5.032 times 10 to the power of minus 4. 5.032 times 10 to the power of minus 4. All divided by actual pressure from the question, that is 1 atm. From here we have that diffusivity AB is equal to 0.1133, sorry, 0.133 centimeter square per second. Using Slattery equation, the diffusivity AB, that diffusivity of carbon dioxide and nitrogen, is 0.133 centimeter square per second. So this is for part 1. If you have not liked and subscribed, make sure you do so. Make sure to share. If you need the property table, make sure you notify in the comment section. So we'll be going for the second part, that is using Chapman Enskog formula, in the next video.